Hey, good afternoon. Today I'll be going over Chapter 5, Question 10. And the question is: two workers are sliding a 300 kilogram crate across a floor at constant speed. One worker pushes forward on the crate with a force of 380 newtons, while the other pulls in the same direction with a force of 350 newtons. Using the rope connected to the crate. Okay, what is the crate's coefficient of the kinetic friction on the floor? So to start off, we'll be drawing a free body diagram. So I'll draw my box here. Now on the problem, we have one worker. He is pushing this massive box. And the other, he is pulling. So either he's pulling it by by the box itself, or by a or we'll say by a rope. So both of them are pulling. Now add our constants into the free body diagram. So first of all, we'll have force of friction, which will be going this direction if we were pulling. Followed by that, top we'll have normal force. Normal force in order to keep the box down onto Earth, and so it's not floating up. So it's not magically floating up. Then we'll have force of gravity. Force of gravity keeping it down. Then we have our tension force. Tension force, and finally we'll have our force of push. Now, according to Newton's first law, an object is at rest or will remain on constant speed unless acted upon. So, as we know that it's being pushed and pulled at the same time, we will have equilibrium. So our equilibrium equation will be E f of x equals to, now we'll take our functions here and I will write them as P for push plus tension minus our coefficient times newtons equals 0. And our second equation being E is F of y equals force of newtons minus the weight equals 0. Now we have two equations, but we need them both to combine them into one equation. So we won't be needing newtons on this one, so we'll subtract newtons from both equations algebraically. But we need to get weight up here, so we'll add weight here to our equation, and our equation will be P, so force of push plus tension minus our coefficient times weight equals 0. Our coefficient will equal to kinetic friction, but we need to solve by coefficient and friction. So with that, doing more algebra, we will equal coefficient of kinetic friction will equal force to push plus tension equals to the mass of our box times gravity. Now, based on our hints, we know the box is 300 kilograms. So on the bottom will be 300 kilograms times, we know force of gravity is 9.8 meters per second. meters per second squared. And we're dividing it over our push and pull tension. So we know force to push is 380 newtons. And we add it with 350 newtons. Now we'll solve it. So calculating the top. So if we calculate, top will be 730 newtons. That is the total force being enacted upon the box, divided by newtons, divided by times meters per second squared. So, and that will equal out to our number. So combining these two fractions, oh wait, I messed up. We already multiplied. That's my bad. So 700 divided by 294 equals out, but rounded out by two significant figures. We'll get 0.125 times newtons per meters. And that is the answer.